Hello again. With our last two videos, we wrote some code to pull data from an API and developed that code into its very own function called park-wide visitation. Getting pretty pro over here, so let's kick it up even more by implementing some iteration. To stay on this NPS visitation train, let's write some code that will perform our park visitation function across multiple years, then combine those annual data frames into just one data frame. There are two basic ways of accomplishing that. The first one being for loops. So we'll do that one first. For loops are the base R iteration tool that executes chunks of code, including functions or even multiple functions, across a list, a vector, an array, and so on, that the user provides it. I want to pull park-wide visitation data for, I don't know, how about the year 1989, 1978, oh no, that might be a little too far back, 1999, 2001, 2020, and how about one more, 2011. The basic structure of a for loop is for parentheses I in 1 through the length of our vector, which is years, meaning for each object listed in our years vector, then we're gonna, much like functions, put the code we want to perform on each of those years in curly brackets. Ooh, except I didn't close the parentheses here. So that's the first thing we gotta do. Ooh, and I didn't do something else that's also very important about for loops. So we want to run some sort of code on each of our years, right? Well, where is that data going to be stored each time we run it and return that final data set for each one of these years? So what we actually have to do is create an empty list to store each year's park-wide visitation results into. So I'm going to call it this empty list output loop for loop. And how you make an empty list is we're going to create technically a vector, but then it's not actually a vector. It's going to be a list. Because remember, these are data frames. We can't store data frames into a vector. And we're going to make that list the same length as the number of years that we have, which we are able to do using the length function, length of our years. So basically we're saying we want the length to be 5. Let's run those two things. And now let's get back to work on our for loop. So we're saying for each one of our objects within our years vector, we want to perform park-wide visitation feeding our argument year, each year in our years vector. So how we explicitly tell it we want to do one after the other, we use a single bracket with I inside. Then we want to save the output of our park-wide visitation function, which is, if you remember, final data, in our output floop. And we tell it where we want to store it in output floop by using double brackets. So basically this is saying that in the output floop ith's list, we want to save ith's year's output. So let's see what happens when we run this. Oh, sorry, I'm gonna just run everything. Don't need our test anymore. We got our years, we've created our output floop list. Now that the output floop list is created, we got park-wide visitation function. This should run. And let's see what output floop looks like. Indeed, it is a list with each one of these nested data tables giving us the year of data that we listed. Because we know that each one of those lists is identical as far as its data structure, since it was produced using, the exact same function, we can actually combine all of these nested lists together using the function bind rows. So let's call that multi-years. We want output floop, and then we want all of its listed data frames to be bound together. And sure enough, we now have this nice singular data frame with each of those years of interest listed. So that's our first option. The second option is mapping. Mapping is the tidyverse's approach to for loops. For loops are great, but like I mentioned and actually saw me experience, you have to do that first step of creating an empty list to store the data in, and it's very easy to forget that step. So what's nice about mapping is you don't have to do that step at all. The map function itself automatically creates that list for you. So for mapping, here's the architecture we're going to use for that. For comparison, let's call our product of this iteration output map. We're going to first call on our years vector that we created up here. So actually, I'm going to move that out of this, since we're using it for both of our iteration approaches. But we're going to first provide years, then we're going to pipe it into the map function. We're first going to insert a tilde, which tells our map that whatever's coming to the right of the tilde needs to be performed on years, while we want to perform park-wide visitation, where we use our argument year equals, because this is tidyverse function, we can put that period there to let it know that we want to perform not only the function on our years, but use our years vector as that argument that we want to map over. So let's see what happens when we run this guy. What you'll find is, take my word for it now, but an identical list is what our output floop provided us, which means that we can also bind the rows in a similar fashion to how we bound our rows in output floop. I'm going to call it multi-map years. So we're going to output map and then bind rows. And you'll see here it's got the same number of observations, it's got the same number of variables, and in fact all the data looks right, but there's another additional step for me to prove my point that they're identical. We can use the identical function where you provide in the as arguments the two data sets that you want to compare to make sure they're identical. We want to compare our multi-years with our multi-map years. Let's see. It says it's true. So this is giving us true, meaning that they are in fact identical. If they weren't identical, it would say false down there. That completes our lesson 3.1, our markdown. Stay tuned for 3.2.